So we're going to be doing operations, multiplication, and division with scientific notation. But first we'd like to start here. And I'm going to change it to my favorite color. 73,000. So I'm going to write 73 and I need it to be in the thousands. Then 1.35 million. So 1,350 and I need to make it million, so there it is. 182 thousandths. Okay, so some of you are wanting to do it this way, right? But that's not what it's asking. Do you see how it says thousandths? Okay, so that means that this right here has to be in the thousandths place. So this is going to be 0.182. Then it wants it to be in scientific notation, and this I will do 1, 2, 3, 4. So 73,000 is bigger, so that means it is going to have a 4, and then we put 7.3. This next one, 1.35, because I put a decimal point right here. I've moved my decimal over 1, 2, 3, 4, 5, 6. So 10 to the 6th. This one, I went from 182. I made it, it's a decimal spot. I need to move it over. So 1.82, but that is lower than 1. So that's negative exponent. We only moved the decimal spot one time. Okay, so this next thing, we're going to be doing operations. Multiply and divide the numbers in front. So if I'm looking at this, I'm going to multiply these two numbers. Then the next part says that I'm going to add and subtract the exponents. So add or subtract the exponents. Write your answer in standard form, and then this chart is backwards. So here we go. So this very first thing, remember 3.72 times 10 to the 8th over, because that says division, 1.2 times 10 to the 6th. So this is the same thing as saying 10 to the 8th over 10 to the 6th. And I know that I haven't let you guys use the shortcut, but all we are going to do is subtract those exponents. So the very first thing we're going to do, we're going to divide 3.72 by 1.2. And when we do that, we get 3.1. The new exponent, I just did it with you right here. So we're going to subtract 8 minus 6, which will get me 2. So the scientific, I write down the mantissa times 10 to the 2nd power. Now to write that in standard form, since 2 is a positive exponent, that means 3.1, we're going to make it into a bigger number. So if I have 3.1, I'm going to make it bigger and go 1, 2. So my answer is 310. This next one, this is multiplication. Okay, so I'm going to take 3.5 and I'm going to multiply that by 5.2. That's how I get the new decimal. So if I multiply those two together, I'm going to get 18.2. Now, to get the new exponent, I have 10 to the negative 8 times 10 to the 5th. So when I do this, I add the exponents. So negative 8 plus 5 will get negative 3. Now, if you look at this, this is not going to be in standard notation for us. We need to actually make it into standard notation. So I need to move that decimal over. And since 18 is greater than 10, that means we're going to be adding. We moved it one time. So this is going to be 1.82 times 10 to the negative 2. And 1.82, it says that this is going to be a small number because it has a negative exponent. Move it over 2 times. So 0.0182. Next, again, this is a division problem. So I take 6.4 times 10 to the 7th. I divide it by 4 times 10 to the 3rd. So I divide the 6.4 by the 4. And when I do that, I get 1.6. Then 10 to the 7th over 10 to the 3rd is the same thing as 10 to the 7 minus 3. And when you do that, you get 10 to the 4th power. So I write that 1.6 times 10 to the 4th. Then I need to make this in standard form, 1.6. I need to make it bigger because that says 10 to the 4th power. So I'm multiplying it by 1,000. So 1, 2, 3, 4. So I get 16,000. Okay. This next one, again, we do the same thing. We take the 2.7, we multiply it by the 1.4. When I multiply those two numbers together, I get 3.78. Then I take the 10.5 and I multiply it by the 10 to the 5th times 10 to the 3rd. So I'm adding my exponents. If you really want to write it out, you can. 4, 5, 1, 2, 3. But you'll get the same answer. 10 to the 8th power. The mantissa is correct, so we're going to write it down. Times 10 to the 8th. Now, since 8 is a positive number, I need to make 3.78 to a bigger number. 1, 2, 3, 4, 5, 6, 7, 8. So 3, 7, 8. I was just making sure I had enough zeros. And there we are. This next one, again, I'm going to take the 4.4 and I'm going to multiply that by 3.4. When I do that, I get 14.96. Then I have 10 to the 3rd times 10 to the 2nd. So all I do is add my exponent. Oops. I added it in my brain. 10 to the 5th. Now, if I was going to write this right now just how it is, it's not in scientific notation though. That's the problem. You have to make sure that it's in scientific notation. I need to move this decimal spot over 1. Because I did that, I need to add 1 there. So 1.496 times 10 to the 6th power. And somebody's going to say, why did you add instead of subtract? Because 14, when it was 14.96, 14 is larger than 10. So I have 1.496 and I need to move that 6 decimal spots. 1, 2, 3, 4, 5, 6. And there you have it. Okay, let's look at this last one. Up, we've got division again. 4.2 times 10 to the 3rd, 5 times 10 to the 6th. So I divide 4.2 divided by 5. When I do that, I get 21. I have 10 to the 3rd over 10 to the, oops, I wrote the 6 as, okay, so I'm going to subtract my exponents. When I do that, I get 10 to the negative 3. Okay, so if I was supposed to write this just how it is, the problem is this is not in scientific notation. So in order for it to be in scientific notation, I need to move this over. And 21 was bigger than 10, so I'm going to add, and how many times did I move over? 1 time. So I get 2.1 times 10 to the negative 2. So if I have 2.1, it says negative, so that means I'm going to make a smaller number. If I went this way, I would make 21. That's a bigger number. I need to go this way 2 times. So 0.021. Awesome. Okay, so let's go to the next page. It says an oil tanker is approximately 1,400 feet long. How far would 9,500 oil tankers span? So if I have this amount, and I have another one right here, and another one right here, let's say this was 3 feet, I don't know, and each one of them was 3 feet, wouldn't I just take 3 times 4, because we have 3 feet long and 4 trucks? Okay, so we're going to do the same thing here. Now, you could take 1,400 and multiply that by 9,500. That is true. But since we're doing scientific notation, we should probably do it using scientific notation. So 1,400 in scientific notation would be 1.4 times 10 to the third. 9,500 would be 9.5 times 10 to the third. So if I was to multiply these two together, I would get 13.3. If I add the exponents of 3 plus 3, I would get 6. But that's not in scientific notation. I need to move that over one time, and because 13 is bigger than 10, that means I would add, and I moved it one time, so add 1. So 1.33 times 10 to the 7th. Okay. The Scoville Scale measure the hotness of chili pepper by the amount of capsaicin it contains. And let me just tell you, capsaicin is hot. It is a chemical that puts the heat in chili peppers. The number of Scoville heat units indicates the amount of capsaicin present in the food. The table represents the Scoville ratings for a variety of peppers. Okay, so I want, it says how many times hotter? How many times hotter? So I'm looking for the mildest law enforcement grade. So I go over here and I look down, and right here I see law enforcement. So I look next door. Which one's the bigger or the smaller of the two? Milder. So 5 million. Now in order to figure out how many this is hotter than this, we're actually going to do division, boys and girls. Okay, so then the next part says the hottest peppercini. So I'm going to come over here, and I see peppercini right here, and I want the hotter one. So that's 500. Now, we could just divide that out, but that's not what it's asking us to do. It wants us to do scientific notation. That's the whole point of this. Okay, so this has an exponent of 1, this has an exponent of 1. 5 to the 1 minus 1 times 10 to the 6 minus 2. 5 to the 0 power times 10 to the 4th. Well, what's 5 to the 0 power? 1. So that's the same thing as saying 1,000. So 1,000 times hotter. Okay, so this next one, I'm going to change colors just because. How many times hotter is the hottest red Savina habanero? Red Savino. Hottest. 570,000. Over. Mildest jalapeno. Jalapeno right here. And then what's the mildest? So 2,500. So we want to write that in scientific notation. So 5.7 times 10, there's 1, 2, 3, 4, 5. Over 2.5. 1, 2, 3. So I divide. You do 5.7 divided by 2.5, and you do times 10 to the 5th over 10 to the 3rd. That will get me 2.28 times 10. 5 minus 3 is 2. So that's going to be 228 times hotter. Sorry, I forgot what we were doing. Okay, so the next thing says the distance from the Earth to the Sun is 1.5 times 10 to the 11th meters. The speed of light, okay, so the word speed, the word distance, is 3 times 10 to the 8th meters per second. What is the average time it takes for light to travel? Hopefully you have learned in your science class something that looks like this. Now, when you're in math, this S is usually an R, but same thing. So we have the distance, we have the speed, but we're looking for the time. So I need time to be by itself, so I'm going to divide by S. So I have distance divided by the speed of light, which will get me the time. So I'm going to take the distance, 1.5 times 10 to the 11th over 3 times 10 to the 8th, and that'll get me my time. So I'm going to take, oops, did the wrong thing, 1.5, and we're going to divide that by 3. And then we're going to take 10 to the 11th and divide that by 10 to the 8th. 1.5 divided by 3 is 0.5. And here we're going to subtract the exponent, so that's 3. But this isn't in scientific notation. So we need to make it into scientific notation. So I'm going to move this over. Well, 0.5 is smaller than 1, so that means I'm going to subtract, and we moved it 1 time. So 5 times 10 to the 2nd power, and that's seconds. Okay, so that would be 500 seconds.